Today we're talking about the McGill Baja Racing team. They're a student team that build vehicles and compete in a few different places in the world, mostly Canada and in the United States. And today we're talking with Jemma, who's been on the team for about 2 years. We'll be getting insights on what it's like to be on the McGill Baja student team, as well as how she applies mechanical engineering to the design of the cars. This is Gen Z Insights, part of the Gen Z in STEM podcast, where every week during summer an episode is released. We feature members from Gen Z studying in STEM fields and doing amazing things. Let's get to it. So, welcome, Jemma. Today we're going to be talking about, mostly the McGill Baja Racing team, but a bit also about mechanical engineering. So yeah, can you maybe start off by giving us a brief introduction on who you are?
Yeah, thanks so much for having me, Maya. So, my name's Jemma Pooley. I'm currently attending McGill University in Montreal, in Canada. And as you mentioned, I'm studying mechanical engineering. I'm going into my third year next year, which is really exciting. My family is currently in Ohio, so I often travel back to the US for work or to see them. So currently, I'm at an internship in Michigan, quite close by to them, which is nice. And also, like you mentioned, something I'm really passionate about at school is the McGill Baja Racing team, where we essentially build a single-seater off-road car to compete every year. So yeah, I'm excited to talk about it.
Okay. Well, you've already mentioned quite a bit about yourself and also a tiny bit about the Baja team. But do you want to maybe give like a bit more in-depth explanation on what like the racing team does and who you are?
Yeah, of course. So the Baja Racing team specifically is a, one of the many automotive racing teams that are organized by SAE International, which I think is the Society of Automotive Engineers International. So they create solar car racing. They have electric, Formula Electric, Formula One type, and so Baja is kind of a subset. And we, at the beginning of the year, the competition says, here's a thick book of rules that you kind of have to follow so everyone stays safe and stays on the same playing field. And here's a mandatory engine that you have to put in the car to kind of, again, level the playing field and make it safe because you don't want people experimenting with their own combustion engines, just, as freshmen in high school, or as freshmen in university. So then from there, your whole team has to organize the costs and organize who's going to work on what, and especially, one of the biggest parts, the assembly and integration of all the pieces of the car together throughout the course of the year. So people tend to start, brainstorming in the summer and then start the actual process during the school year. And then by the time May rolls around, you start some competitions in the summer. So we have, I think, around 80 schools, 80 to 100 schools that will compete over the course of 4 days to race these cars, both to test kind of, I think, I don't know if we'll get into maybe a bit more later, but I think something that's really cool about Baja versus some of the other teams I mentioned is that we really have to create kind of a, like a car that's ready to be roughed up and ready to be thrown around in a race. Kind of if you would imagine a buggy or like a motorsports, bike. They're kind of going off jumps, they're going up hills, they're going off rocks, and like if something breaks or gets bent, you have to be able to run in, swap it, and all that kind of thing, which is, those 4 days really tests all the components of your car, which is just really fun to see.
Yeah, it sounds super cool. But then, how did you even like get interested in joining the team? Or like, how did you find it?
Yeah, that's a good question. I think for me, I chose to go into engineering sort of because I didn't really know what I wanted to do out of high school. And, I seemed to enjoy my physics courses and I wasn't terrified of maths. And so I was like, okay, maybe I'll try this engineering thing. And then I kind of relied on at school, maybe I'll find something that I can, kind of pour my heart into and actually get that passion for engineering that I was kind of seeking. So during one of my first days at school, they have these orientation fairs where you can go around and talk to different clubs and talk to different student activities. And one of them was this Baja racing team. And the first thing I kind of really liked about it was the people and the cohesiveness of the team. Everyone there was really excited to tell you everything about the team and about what they do and what they're excited about. And I was like, oh, like that's really cool to have that much, passion and excitement about something. And then once I started, attending a couple of the meetings or, messaging people saying, oh, are you in the workshop area? Can I come by and see what you're doing? Started looking a bit more into it. I found that it was a really fun time I just learned so much in those first few days of trying it that I eventually was like, okay, I want to stick through and see what happens. And it's been really amazing so far. Not, I wouldn't say it's just a Baja specific thing to have that kind of passion for something. I know lots of the other teams, people are really passionate about robotics or about bridge building, but it was really fun for me to be surrounded by lots of those mechanical engineers who are so passionate about it, and I can contribute and help and also be really excited.
Yeah. And then also, so you've mentioned like there's lots of like different components to it. Like some people even you do everything. Like you do the costs, you do like I saw on your website too. Like you have ads and you need to get like sponsors to be able to build, like this like vehicle. So what like parts have you been involved with, and like what role do you have in the team?
Yeah, so my first term with the team, I was still, I had the intention of trying out those different components because the way that we've structured our team at McGill, and I think it's fairly similar at other schools, is we have a student or a couple of students lead one of the sub teams of the car. So we have 9 sub teams. I can name a few. I think it's, the transmission, the powertrain, the drivetrain, the suspension, the frame. So they are larger categories, but they're still quite, you know, defined in what they do. So the frame isn't going to try to design a gear, or, the people doing brakes aren't going to try to mess with how the gas tank is mounted. So it's all those different, quite different components, but that's where I mentioned when people have to all come together. So anyway, in those subsystems, I really had the intention of trying out maybe a small project in each one, or seeing the people and seeing who I would want to work with and continue with. But it turned out that eventually they just really wanted someone to help with the gas tank that they were doing. They get a gas tank from the competition again for those safety reasons, but they needed someone to make a couple brackets to mount it onto the car. So they had seen me kind of coming in and wanting to help out a lot more. So they gave me that opportunity. So my first time I was helping out just with some of the gas tank order parts and those brackets that we manufactured. So that was fun. And then later, we actually had a student graduate in December of that year. So they'd already designed some components of the transmission cooling, which is just we have a continuously variable transmission. So there's just a lot of friction happening. So they made like a fan design to help it cool down. So I was in charge of then taking that on and manufacturing it and seeing it through. So I stayed with that for the rest of the year. And then this last year I was at school, I did the actual parts of the actual transmission and helped them out with that. So it's been really nice. I think some other people on the team have had more varied experiences. I've seen people go from, first year being a general member, kind of seeing what everyone's doing, helping out here and there. And then their second year, they did steering, and then the year after they did suspension. So it's kind of trickling into that bigger subsystem through trying out little things first. So, but yeah, that's kind of what I've had experience with.
Wow, it's really nice. But then also, I want to touch upon how like that kind of also relates to like mechanical engineering, because technically, like you're really like getting this like hands-on experience. But I'm curious, like, do you get like, for instance, the courses you have, do they help you with the team, or is it more the opposite, and you just get there and then you learn everything when you're with the team?
Yeah, I think honestly it's a bit of both because at least for us at McGill, we have a very kind of theoretical base for our education, and it's lots of it is really great, and I've really enjoyed lots of the classes I'm in. But as an example for how I think it gives you a good starting point is things like our deformable solids class, where you start learning about FEA analysis and how things can deform based on their material or their geometry and that sort of thing. we have a small project in that class where you do like some of these hand calculations for all of these little pieces in a big part, and it's all just really like, okay, but what are we going to do when we get to a job and we have to do this stuff? And you kind of start it, like maybe you start one SolidWorks FEA, but at the on the team, you do have a base of, I know how it works, I know how to define from then, your dynamics class and your was it your statics class, you know how to define forces and how to define that sort of impact system. You can apply that with the theoretical of the deformable solids and maybe some of the, solid mechanics from, I had like a civil engineering class where we did solid mechanics, and you apply that all into, okay, you basically have one problem where, say, I think I had a component of mine that was a shaft that was bending under load. And so I had to first, you have to know how to CAD and how to kind of bring it up into um, a place where you can see all the components without just kind of guessing from a physical feature. So you have that base of what the component is. But then you're able to use that base from school to say, okay, well, I know it's, this kind of cantilever beam essentially, and you learned a lot of those equations or those properties. And then you can, cross-reference it with a simulation where you have a base from that FEA deformable solids class. Did it deform how I expected it to? And often I think the team helps you take it a step further, where I think lots of the things on the team that have helped me are things that would kind of just brought to my attention, as in, why are you doing it this way? There's a really cool software or there's a really cool method that people use in the industry or that we've been using as a team that you should really use as well. So things like that, I think, are really refreshing because you can use your equations and your like list of all the things you learned in class to solve this one problem. But then, say we're sponsored by a company that has a software that helps you do kind of all of that and more. It's really nice to see that and then actually apply it.
Yeah. Wow. Okay. And so then, like, what has been like the value? Because I think you touched upon, it helps you like grow and like be able to, I guess, develop and really like in your projects like apply what you've learned and get advice from others in ways you can do it differently. But then, is there any other like skill sets that the Baja team has brought you, or like value that it has brought in your life in general?
I think one of the more valuable things has been kind of asking for help or asking for some of that clarity because at school, sometimes I guess it depends, in projects maybe you have someone in your team who's really confident and can really instruct everyone how to do lots of the work, or you guys do it the way that your professor outlines you to do it. But it can be really scary if you're on a design team and it's like it's not for a class, there's no one who's done it before you, and you're kind of like, I don't really know how to start or how to continue after this hurdle. So for me, that was a bit of a struggle starting off because I would start trying to do something one way and get really fixated on it and say, oh no, well, I'm still working on it. Like, don't worry, it's still going. And eventually I felt comfortable enough to ask my team members and even some other team members. We work in the same space as our Formula Electric team. So at one point I was asking them more because they do more aerodynamics than we do. So, it's nicer to have that input from people with experience, but it took a lot for me to be like, hey, don't really know what I'm doing, but I really want to get, see this project through in the way I've kind of envisioned. Can you help me? And I think that's helped as well with my now future internships and future school initiatives and everything, just learning that it's okay to ask or admit when you're not super comfortable or not super, in the right place or in the right state to continue your project. And then you can ask for help really anytime, especially when you're surrounded by lots of your peers. And I've just found it now feels like a more safer and collaborative environment than feeling responsible for this whole part of the car that might not work and it's all my fault. Like, it's okay and everyone's there to help. So I like that's one of the biggest things I've taken away.
Okay. So, what has been your favorite experience with the Vajo team?
I think, let me see, there's a lot of kind of things that happen that then tend to bring us all really close together as a team. One of the, I think, maybe slightly more stressful things at the time that then I see as a really nice memory going forwards is like, I think it was a couple years ago. We have a competition that happens before our summer competitions. So it's sort of like a, you can imagine it like a scrimmage, like a precursor to the competition, but the caveat is our car for that year is still not finished because it's like February at that point. So we bring older cars to compete and get new members involved and just kind of race them and fix them when they break down. So I think we taken 3 cars that year because we were like, oh, they're running, People normally take 1 or 2. So we're like, oh, let's take 3. It'll be fun. More people can drive because we were also bringing, I think, 25 people or something. It was a big team. So it was in Quebec City. So all of the local Canadian schools came up and we were at Université Laval, I think. And we were just going around their campus and it was with the wind chill, minus 40 degrees centigrade, like something crazy. And you can kind of imagine we have like I was a new member at this point. And, I'm excited. Oh my gosh, competition will be so fun. And I'm as soon as I walk outside, my eyelashes are like, have huge icicles on them, and I'm trying to blink so they melt, and it's really kind of okay. That's a rugged environment. You can imagine then how we've just brought cars here. Like they're supposed to run and they're supposed to go around this track. And for the most part, the first day was okay. But then as time went forward, I was trying to help our transmission team because I knew eventually I really liked that, that team and that work that they were doing. So I was helping them with getting the cars ready. And one small feature of the competition is when you go to do technical inspection where the officials of the competition check over every inch of your car and they say, okay, this weld is appropriate, like this seatbelt fastening mechanism is fine. Like they have to go over everything safety wise and playing field wise and make sure your car is rules compliant essentially. To do that, you have to take out the transmission just so it doesn't lurch and run someone over by accident because they also test that the engine's working. So if they turn on the engine and your transmission isn't set up correctly, it could start driving. So essentially, whatever, they take out the transmission, and then the transmission team for the next, I think, 20 or 30 minutes, we're each taking turns. And the other thing is when you put in the transmission, it's basically these 2 pulleys that you just put on the side of the car. So they're cold, hard aluminium pulleys. And you can't fit gloves in the compartment that they're supposed to go in. You take off your gloves, maybe put on the little blue gloves or something, and touch this freezing cold metal to put it in. I think every single one of us got some version of frostbite. Like, not to the point where, like, our fingers were white or black or anything, but it was just so painful. Everyone was like, no, 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 like, I got it, I got it. And everyone's like, yo, you have to go inside, it's too cold. Like, it was so frustrating and so kind of like, a tough situation because everyone was like really trying to get it finished. But then with that specific, I think the other cars, they went in okay. But with that specific car, it was just like not happening. I think the shaft was steel and the transmission corresponding shaft was aluminium, and they had just it gotten too cold for them to actually still be, you know, a non-interference fit. So they sadly then that car didn't get to run. But I think it was still really fun because I got to learn a lot more about the car and I got to actually help out because we had to take turns doing this really crazy task. But it was those sorts of things at competitions happen, and then it's nice because everyone has that all hands on deck approach, and they all kind of flock in. What do you need? How can I help? How can I help diffuse this or help, get essentially just get the car running again? And so it's important that you have people who know what to do on that subsystem. So the transmission lead was, I think, the one at some point who was like, okay, we have to stop. Like, this isn't going to work. Let's continue and focus on the other cars. yeah, it was a fun experience, and the rest of the competition was really fun. So lots of people got to drive and crash the cars and do all that kind of stuff. So
Wow. Yeah, it sounds so exciting. And also, like, you work on the car and then you get there and the conditions are maybe different than what you might have thought. So it might be stressful, no? To like
yes.
be in that situation and like, is it gonna work? The official's gonna be like, is this approved? But it's a really cool
Yeah,
experience.
it can be very humbling sometimes because there's multiple levels on which you're tested because the rules thing is important. I think recently at our previous competition just this summer, we got in trouble because one of the rules had changed but like during the school year that we didn't realize. So it wasn't like a thing where the car doesn't work otherwise. We had just had to hammer some sheet metal into place somewhere. That was kind of a shock because like, okay, well, that can't happen again. Like we need to be checking these rules more frequently, but um, that can happen. And then also when you're also evaluated on your design, so the whole team does a presentation of every they break the sub teams up into five, I think. So they have vehicle system, which is the whole vehicle. So normally, like the captain will talk about how cohesive the vehicle is and how everyone worked together, and then how it's tested as a cohesive vehicle, as opposed to like testing a single component or whatever. So it's actually quite hard. So that's like one presentation. Another one is powertrain, so it includes transmission and drivetrain. And then there's SSB, which is suspension, steering, brakes. There's ergonomics, so they categorize them much more loosely. So we have multiple presenters at each of those. So during design, they can also be like, why did you do it this way? Or like really kind of get to you about the kind of like they don't often grill you about that sort of thing, but it can be the fact where if you say something like, oh, well, based on last year's design, this didn't work, so we used a different material. And then they're like, but you didn't actually test the difference. You didn't follow through with an analysis. Like they come at you a little bit. So that's also something that can happen at competition where you're like, am I ready to present? Am I ready? But it's the team has also done a good job of helping everyone ease into it and get confident with their designs. And I think especially post COVID, it's been tough for a lot of teams because their population curves kind of went from a lot of members to like few, and now they're growing again. So we have to keep up that knowledge transfer and keep up that confidence to help people, go through and take some of those roles.
Yeah, it's actually like very related to my next point because depending on the amount of people, you have more or less work to do, right? And for instance, in my university, we have student teams, but student teams very often a big part of their teams like take a year off, like the whole year they're just working on the like vehicle or whatever they're doing. For us, we have like solar boats and stuff like that. So you guys like do this alongside your studies, like in the same time. So how like are there challenges to like doing this like team in the same time as like your studies and balancing that and your student life and all that?
Yeah, I think it's definitely interesting because of also the range of years that we have participating in the team at a variety of different levels. So I think often we have the first years helping with a subsystem or doing tasks to help out with the car in general to get that wider understanding of the team or of the maybe they can help out with a specific subsystem that they'd like to eventually join so they can specialize in that sense, but they have less of a commitment load on purpose because it's their first year at university, they're still learning everything, and they also need to learn about the team. So it's that some of it is structured where then as you go and maybe as your degree gets a bit harder, you do have more Baja responsibility as well, and that's where you kind of have to decide with, do I need multiple people to lead this one sub team? Even if it's if it's historically a sub team where one to two people can do it, and then you suddenly have a year where three or four people are doing it. Sometimes it's necessary because of how everyone's feeling and how everyone's schedules sort of go. The one kind of issue that we see with that is we don't have the amount of people to assign three or four people to a sub team often who are the leaders of that sub team, because often you have new members who will help out, so the whole team becomes like 6 to 8 people. But for those leaders who are actually designing and actually planning the car, you need to have confidence in them that they can all deliver it. So sometimes it's a bit tough from a leadership side to feel confident in, okay, I'm excited for this all to come together, when you're secretly like, okay, but do we have the personnel and the amount of time to get it all finished? There's that. I will say, to go off of something you mentioned with people doing it year round, we have had in the past people using some school projects to contribute to Baja. So for people's final year, they often do a capstone, which isn't the whole year. It's basically just one class, that they do for the whole year, but that's still how many, like, more than 3 hours a week that would be classes that's now dedicated to Baja and that development, and they just submit a paper or something on the Baja progress that from their system to their thesis supervisor or to the capstone supervisor. So we have people who do specialize during the school year as part of their schooling, but it's still very difficult to gauge when school, when tests and exams ramp up and people kind of get a bit more antsy. It can be very difficult, which is the other thing really quickly that I want to also mention with it is it also just depends on how our sub-team leaders organize their sub-team, because we had a member who was doing the pedals subsystem, and he was really, I think he was in his maybe second year at university, and he was really wanting to focus on school and focus on his classes and exams and everything. The competitions are in May. The car should ideally be finished by March. So normally it trickles into April, but he finished his entire subsystem before April. So like, I'm not going to work on it during exams. A personal kind of boundary. He's like, I'm not going to do that. But instead of just saying, I'm going to drop out during exams, he took the initiative to finish and plan his subsystem to get to that point. So I think sometimes that helps, where you don't have to make a huge design change. You don't have to make a revolutionary idea. And, because that would take a lot of people. You don't have to do that every year, especially if we're a competitive design team. Like, you don't have to reinvent the wheel every year. So focus on something that you can also plan to then do the other things you want to do, whether it's school or whether you want to do other activities or other clubs. I think it overall just depends on how you organize it. And it's that sort of initiative, I think, was really good for people to see. And I think it's important for now our leadership to say, hey, this is what you can do, and just tell people who are worried about those sort of commitments, it's, don't worry, you have an avenue to try and have it all work out.
Yeah. And so lastly, if someone's like considering joining a student team in their university, like what would you tell them, or why should they join a student team?
Ooh, yes. I think, well, I think student teams are really nice, kind of, as I mentioned a little bit at the beginning, they bring your studies, what you learn from your classes, to the next level of it. They allow you to apply it, and like normally, like sometimes for us, you do get projects in class where you can try, you try out the things that you've learned, but sometimes it's structured in a way where you learn a certain chapter or a module, and then you do a project on that module, and then you do the next one. And so you kind of know what to do for that project or for that experiment or what have you. But for us, often, you're starting with this problem that's maybe been a problem for years, and you have to try multiple things and throw multiple ideas and different techniques to try and solve this. So not only do you get to apply what you do at school, but you also get to have the experience of, well, I learned this in the class, maybe I'll try this. Okay, that didn't really work, let's try it a different way. What if I get input from an older member about a software or something they've used to help them? It kind of brings it all together. I think the other small thing that I've realized is the more intricacies of having a non-school project that you have to do. Because even with the capstones, or with some of those thesis projects, where you do have the freedom or the liberty to do your own thing and it's not outlined. Sometimes you don't really have a huge pressure with regards to cost or timeline. You often outline that yourself. So even for capstones, they often come up with a prototype at the end, or they're saying this is what it will look like, that sort of thing. But for us, it's more we have a timeline and we have a budget that we really can't stray too far from, which makes it a bit stressful, but it allows you to say later, I was able to do all this, but minimize that cost aspect, or I learned how to prioritize cost in a design. And it's something that's really different from what I experienced in the past. And I think the last thing is that you make a lot of really good friends. And something I really enjoyed about doing sports and stuff in high school was meeting those people from different age groups and meeting those different years of high school. And so in university, I'm really happy that I can do something else, such as this design team where you have members who are in their last year of school, maybe, their fifth year of school, members who are in their first or second year, and they're all coming together and with, mutual respect and mutual excitement to work on this project. And that's something I think is really unique to design teams. And then for which design team you're going to do, it kind of depends on those specific people, if you enjoy them, or if you think, I don't know, I think sometimes there's different dynamics and you can see what you like. And then if you already have an idea, I really like the solar energy or the green kind of thing, you can go for electric or solar cars. I think then from that point, it kind of depends on some more research, but joining a design team, I think, is a really good and really cool experience for those who do have the time and have that, the excitement to continue. So
Yeah, and from what you said, it seems super valuable because you get to learn from others and then also put your ideas into practice. And
Mhm.
yeah, it just seems amazing. But
Yeah,
yeah,
thanks.
so yeah, thank you so much for coming on today and talking about the Baja team. Like, you seem really passionate, and yeah, I hope that passion shines through to people and they join.
Oh yeah, thanks so much for having me. It's been really fun. So yeah, I hope people join design teams now. They're cool.
Yeah. Now link your the website because it's a really cool website. I've got to say.
Thanks. Sounds good.
If you made it here, thank you. We talked about all things Baja. And thanks to Jemma, we know now what it's like to be on a student team and how it can benefit your studies. I hope this was insightful to you. And every single week this summer, we're going to be releasing an episode of Gen Z Insights. So subscribe, follow on LinkedIn or Instagram, and stay tuned because we will be back soon. Bye.